This is video number 1 for chapter 9, section 1, which is about the Pythagorean theorem. First off, we are going to talk about what the Pythagorean theorem is. I'm guessing most of you have at least heard of it before. Some of you may have used it before. And the Pythagorean theorem works specifically with right triangles. So if we have a right triangle, then the Pythagorean theorem tells us that the lengths of the legs, if we square each of those and add them together, then that equals the length of the hypotenuse squared. So it's that a squared plus b squared equals c squared. A and b are legs, c is the hypotenuse. Just a reminder that the hypotenuse is always the side of the triangle across from the right angle, and the hypotenuse is always the longest side of a right triangle. And then the two legs are the sides adjacent to that right angle. So let's look at how to use the Pythagorean theorem to solve for a missing side of the triangle. In this case, we have 20 and 21 are the lengths of the two legs of this triangle, and the side we don't know, x, is the hypotenuse. So we can use the Pythagorean theorem by plugging 20 in for a and 21 in for b, and it doesn't matter which one is a and which one is b as long as the hypotenuse is c, and x is our hypotenuse here. So we plug all that stuff into our formula, and then we are going to do 20 times 20 and 21 times 21 to get 400 and 441. Definitely use a calculator for that. We add those together and get 841 equals x squared, which means that we get x being the square root of 841, which again, if you use a calculator to calculate that square root, you get x equals 29. Let's look at another example. So in this next example, we have a hypotenuse and one of the legs, and we are trying to figure out the other leg. So in this case, 11 is the hypotenuse, and 5 and y are the legs. So we plug those in for the particular parts of our Pythagorean theorem. So this time one of our variables is one of the legs. 5 squared is 25, 11 squared is 121. Now we want to get that y squared by itself. So we are going to subtract 25 from both sides of the equation. That leaves us with y squared equals 96. So we get y equals the square root of 96. And now 96, when we take the square root of that, that does not give us a whole number. So we need to simplify this how we learned to do so in our most recent unit. So 96 could be written as 16 times 6. Of course, 16 is a perfect square, which allows us to simplify that square root of 16 into 4. And our final answer is that y is 4 times the square root of 6. All right, so now that you've seen a couple examples of the Pythagorean theorem, you should pause this video and try to find W and Z in these triangles here. So make sure you pause it, because in a second, I'm going to show you the answers. All right, so first off, I'm going to show you your answers. For W, you should have gotten 2 times the square root of 21, and Z, you should have gotten 8. Now, if you didn't get those, maybe look back at your answers, pause the video again, see if you can find where your mistake maybe was. And then if you still can't figure it out, here is the work on how we get to W being 2 root 21 and Z being 8. So for W is a leg. We plug in our values, we get W squared by itself, and we have to simplify that square root of 84, just like we had to for Y on the previous problem. And then for Z, we're trying to find a hypotenuse. So we square 7 and we take the square of the square root of 15. This is something that hopefully you are familiar with, but if not, when we take the square root and then square it, we're always just going to get that number. The square root and the squared are inverses of each other. So when they both happen, they cancel each other out, and we're just left with that number under the square root. Once we've got that, we get 64, and the square root of 64 is 8, because 8 times 8 is 64. All right.